Welcome, intermediate algebra students, to the first video of the school year. Wow, this is something, huh? So in chapter 0, it's going to be, we're going to use some concepts you've already learned, but we're going to do them in a different way that you probably haven't seen before. That might get kind of confusing. So it's good to pay close attention, take great notes, and get ready to work. So in section 1, it's called the same yet smaller. So it's kind of an introduction into this term called recursive, which we're going to use quite a bit this year and a lot in Algebra 2 as well. Well, recursive basically just means the procedure that you do over and over each time, building on the previous stage. And you've actually seen a bunch of recursive, what you would call sequences, right? I bet a lot of you saw this in sequences in math class in middle school. For like if I did in an arithmetic sequence, like 1, 3, 5, 7, we're just adding 2 each time. And geometric sequences where we're multiplying like 3, 12, 48, okay, we're multiplying by 4 each time, things like that. That's kind of what we call recursive, right? It does over and over, building on the previous stage. But this specific section is going to deal with fractals. And that's a design using a recursive procedure. And the most common one, and we're going to look at this here in just a second, is the Sierpinski Triangles. Sierpinski Triangles. Let's take a look and see how recursive works in a fractal. So here we go. I got a triangle. I got some dots. It's just going to help me draw my grid here. But stage 0, okay, stage 0 is like our basic stage. Nothing has happened. We're going to deal a lot with triangles especially, but like nothing has happened to our triangle. And usually unless it's designated, we usually say this is an area of 1. Okay? And eventually it's going to designate and give it a different area. Well, in stage 1, in the Sierpinski, it has a recursive rule, which we'll talk about in just a second. But what happens is, if I go to the midpoint of each side of the triangle and connect those dots, that is my first stage of the Sierpinski triangles. Now, if you notice, I broke it into 4 equal parts. So, if the area was 1 originally, each of these triangles, each of these medium-sized triangles would have an area of 1/4 each. Right? Because they're 4 equal-sized triangles. And it looks like I have 3 upright. Right? 1, 2, 3 upright, and then I got 1 facing downwards. Okay? So stage 2 gets a little bit trickier. So that means we're basing it off of stage 1. So get my midpoints again here. Connect those dots. A little sloppy this time. Sorry about that. Okay. So for stage 2, every time there's an upright triangle, a triangle like going up, the points at the top, we're going to do that exact same thing. We're going to connect the midpoints. So I have a triangle up top here, then I have one on the side, and one down here. So I got to mark the midpoints of all the sides and connect the dots, just like I did in that other stage. You got to follow the same rule that you just did. So every time there's a upward facing triangle, just like there was right away, that was an upward facing triangle. So I made dots at the midpoints, and I connected them. Ooh, it's a little bit tricky now. Okay. Well, now like if I broke this middle one, I could do the same thing to the middle one, but that's not part of my rule, right? There might be something that does that. But if you think about it, how big are these little guys? How much of the triangle is that? Like if I just shaded this in, how much would that be? We're going to look at that in just a second. So if you think about it, I went from stage 0 to stage 1, and I broke it up into 4 parts. And then I took the upright triangles and I broke the upright triangles into 4 more parts. So maybe that's something you start to click at, like how big those smaller triangles are. And this could go on to stage 3 and stage 4. It's going to get pretty big. And if I think about this, if I decided to write a recursive rule, we can write rules when there's a recursive procedure being done. What would the recursive rule be for this? Well, I could write it out in a sentence. In Algebra 2, we're going to write it out in an actual formula. Okay, in this case, we're just going to say, what do? We connected Connect midpoints. I like to abbreviate things. Connect midpoints of all, what kind of triangles? Not all the triangles, but all upright triangles. Or triangles with the point at the top. We connect in the midpoints. So that's kind of a rule. We can actually write a rule for that. You might have to do that in your assignment here. So let's take a look at our Sierpinski triangle. And we're going to find the total shaded area in each triangle. Assume, this is important, always read your directions carefully. Assume that the area of the triangle is 1. Okay, so the area of the whole triangle is 1. Okay? So what's the shaded area now? What is the shaded area? Well, one thing to do, this is kind of a long way, is technically I could break this triangle up and just count all the small pieces and figure out, oh yeah, I shaded 2 out of how many total small pieces, right? We can all write fractions for that. But that might take some time, especially if I have a bigger picture. So how can I find that without actually counting them all up? Well, if we think about it, how many medium-sized triangles? It's good to maybe break up your problem. It looks like I have 1, 2, we talked about this, right? It broke it up into 4 medium-sized triangles. So if I have 4 medium-sized, and inside of that, if I look at this left one here, there are 4 smaller ones. So then I have 4 small inside each medium. How many total small triangles would that make? Well, there's 4 in each of here. Oh yeah, 4 times 4. There's 16 total small ones. So I could have simply drawn it in and counted it all out, but you can think about it just by breaking the triangle up. So there's 16 total small pieces, so 2 of them are shaded, we just saw that, so 2 out of 16, and we always simplify fractions. So 1/8 of the area is shaded. Okay? Well, we're going to be doing a lot with fractions, especially in this first chapter. Okay, so we got to cover our rules. Plus, we're going to look at it on the calculator as well, just because we got to get used to using our TI-84s and our 83s. So first things, adding and subtracting. What's our main rule? You always need a what? That's right. You always need a common denominator. Denominator. Perfect. So in this case, I got to get the 4 and the 8 to a common denominator. I can always multiply them, but that's not the least common. In this case, I want to get this 4, 2, and 8, right? So I multiplied by 2, which means I multiply the 1 by 2. Right? Hopefully, we're all pretty good at that by now. So I got 4 2/8 minus 1 and 3/8. Here's where it gets a little bit tricky. Some, I bet, are very good at this mentally, and you might take away 3/8 from this first fraction. So if I take away 3/8 from this guy, what are you at? 3 and what? 7/8. Right? So if I drop 3, if I drop 2 8s, I'm down to 4. Right? If I drop 2 8s, I'm down to 4. And then if I drop 1 more 8, I'm down to 3 and 7/8. And then from there, all I have to do is just subtract 1, which gives me 2 and 7/8. That's how I would do that mentally. Okay? For those of you that aren't great with your mental math, it's a little bit longer process, isn't it? So hopefully, we're all in high school now. So we should be able to use our calculators to help us out here. Okay, so if you take out your calculator, don't just watch me do this, actually take it out, and let's take a look how this will work. I'm going to try to subtract 4 and 1/4 minus 1 and 3/8. So if you know how to use your calculator, it's going to make it easy. Anytime I'm going to use like fraction bars or things like that, I like to use parentheses to keep track of it. So I'm going to start with the left parenthesis for my 4 and 1/4. Then I'm going to say 4 and, well, how do I get that separation between the 4 and the 4th? I can't just write this, okay, because that's going to be 41/4. That's totally different. Okay, I need 4 and 1/4. Well, you're really adding it to that 1/4. So I can say 4 plus 1/4. Well, the slash is a division, okay? But fractions always mean division. So 4 and 1/4. So there's my first fraction. We're subtracting. Do it in parentheses again. 1 and 3/8. And it should calculate 2, 2, and 7/8. There it is. Oh, by the way, what if your calculator didn't do that? What if you didn't get a fraction? That's because your calculator is not in fraction mode. Let's take a look at how to do that. To get it in fraction mode, you need to click on mode. So once you click on mode, Lots of options. You'll know almost how to do all this stuff by the end of your high school career. So we're going to go down, go down. If you look right here, I have this n/d and this un/d. This first one is just numerator over denominator. That would be like an improper fraction or a regular fraction. The un/d is a mixed number. Okay, so if I would have had this first one selected, I would have ended up with an answer of 23/8. Okay, but I had the mixed numbers selected, so I got 2 7/8. And then right here, answers. Do you want an auto, decimal, or fraction? Well, we want it as a fraction, so you got to scroll over and hit enter to get fraction form. And maybe move down. Okay, it's good. It's in fraction form. So to get out of here, I'm going to go second, quit, right? Anytime I need stuff in the blue, I got the blue quit, I got to go second and hit that mode button to quit it. And now you should be able to get the fraction. So try typing in that same thing. Okay? Our other rule is for what? Multiplying and dividing. Well, we never ever divide fractions. Okay? We never divide. So I'm just going to cross that out. What do we do instead? We multiply by the reciprocal. So we always change the multiplication or multiply by the reciprocal. And we never deal with the mixed numbers. We always change them improper. So I had to take 4 times 4 and then plus 1. So 4 times 4 is 16, plus 1, 17 fourths. Change the multiplication and multiply by the reciprocal. Well, let's get this improper first. 8 times 1 plus 3, so 11/8. Now we got to flip it because we're multiplying by the reciprocal. And remember, anytime it's multiplication, we can cross cancel. So the 4 and the 8 cross cancel. How many times does 4 go into each of them? Well, 4 goes into 4 once, 4 goes into 8 twice, and now we multiply across. So 17 times 2 is 34, and 1 times 11 is 11. And then how many times does 11 go into 34? 3 times, which is 33. So how many are left over? 1. So 33 and 1, 11. And let's go ahead and get practice typing this into a calculator. So like I said before, let's deal with our very first guy right here before we did any changing. So 4 and 1/4. We'll put it in parentheses, plus 1/4, 1 divided by 4. And then we got divided by 1 and, remember, plus to get the mixed number, 3/8. Hit enter, bam, there we go, 3 and 1, 11. Perfect, okay? So it's good to get used to that calculator. Okay, last thing that you might see on your assignment here. This is where it gets a little bit tricky. You got to read very carefully. I'm always going to tell you, reread your directions every time you get an answer. It says, suppose the original large triangle at the right has an area of 24. That's important, the area of 24. What fraction of the area is the shaded triangle at the top? Okay, so we're just looking at this. What fraction of the area? Well, how many of those, that size of piece do we have inside the big triangle? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1/9 is the fraction of the area. Could I actually calculate the area of this top triangle? Sure, I would just have to take 1/9 of what? That's right, our area, 24. So I'd have to take 1/9 times 24, which ends up giving me, it gives us 2 and 6/9, which is really 2 and 2/3. So I didn't really have to calculate that. All I needed was the fraction of the area, but we just wanted to look at that. Then it says, what fraction of the area is the smallest shaded? So this little guy. Well, there were 9 medium-sized, right? 9 medium-sized. And now there's 9 small ones inside that medium. So it's not just 1/9, but it's like 1/9 of a 9th, right? Because we're taking 1/9 of the 1/9. Okay, 1/9 of the 1/9. Which gives us 1/81. So there's really 81 total small pieces. Right, if I thought about it, because there's 9 in this triangle, there'd be 9 in that triangle, 9 in that, 9 in that, 9 in that. So 9 times 9, there'd be 81 total small pieces. Remember how we talked about that just a minute ago? Then it says, what is the total shaded area? Well, let's look at our triangle here. Total shaded area. So it looks like I have 4 of the medium-sized pieces. So 4 of those 9 total pieces are shaded, right? And then I have how many of the small ones? 1, 2, 3. So I have 3 of the, well, how many total small ones would there be? I know there's 9 just in there, but you gotta imagine on the whole triangle. What we just said right here, right? There'd be 81 total small ones. And we gotta add those together, right? Because we're talking about the total shaded area of that triangle. Well, like we said, common denominator. So I gotta multiply by 9 here, multiply by 9 here. So we really end up with 36 over 81 plus 3 over 81. Boom, 39 over 81. Am I done? It kind of feels like I am, but always reread. I'm telling you. Math books just love to trick you. What is the total shaded area? Well, the area of the whole triangle was what? 24. So 39 out of 81 of that whole area is shaded. So we still have to multiply this by 24, or 24 over 1. And here we go. This is where we can use our calculator, so we don't have to go through the math. So I'm going to start with parentheses, or my parentheses again. So I have 39 over 81, and then we multiply by 24. I can put it over 1, I don't have to. And we got 11 and 5/9. So the area of the shaded region would be 11 and 5/9. Okay, so there's some thought process to this. Okay, so take your time, get used to using that calculator, and good luck.